Let's discuss question number 35. This is from test 4 from fluid mechanics. Well, let's see what is given. A gravity dam has the cross section as shown below, and we need to find out the magnitude of the resultant force due to water acting on the face of the dam. Okay, so let's draw the dam. So you have one portion straight and the other portion vertical, and this height is given 30 and this height is 20 and this is also 20. Okay, so we need to find out the resultant of this pressure distribution. So let's take something like this. Let's take it a bigger, slightly bigger. So this is the dam. Okay, so you have water till here. Okay, so if I join this to the vertical, I have basically, due to this water, you have the pressure distribution due to this water being like this. Okay, so this, what I can do is I can the resultant force of this pressure distribution can be viewed as the net horizontal force plus the net vertical force. Okay, the net horizontal force is basically the pressure distribution resultant acting on the projected area. So this is, if I happen to so all this, if I happen to superimpose in this, so this becomes vertical. So on this, the pressure distribution that provides your FH. So the pressure on this would be 0 here, and at the bottom it is Pmax, maximum pressure, which is rho GH by hydrostatic principle. Okay, so rho is 1000, G is 9.8, H is your 30 plus 20. Okay, so this is your pressure distribution, and the resultant force, horizontal force, will be basically, it's a unit width perpendicular. So the FH is basically, this is your pressure diagram. Okay, so FH is basically your volume of the triangular prism, which is nothing but this area into the length. So area into 1 meter depth, meter length. So area is nothing but half base is Pmax, and height is 30 plus 20, which is 50 into 1. So half Pmax is 9810 into 50 whole square. So this value comes out closer to, so if I use a calculator, this comes closer to 12.3 into 10 power 6 Newton per meter square, and so 12.3 mega Newton per meter. So all that, this is per meter square, so this is basically newtons, mega newtons. So I can write 12.3 mega Newton is the horizontal force. So this problem you can do a couple of ways, but this is one of the way. Later I'll tell you the other way. So FH is basically as if the entire wall is vertical and you are just finding out the horizontal force. Now vertical force is nothing but the weight of the water above the column, weight of the water column above the inclined surface, above the inclined surface. Okay, so we need to basically find out how much weight of the water is there in this column. So this column, how do I find out the weight of the column? Is basically, this weight is nothing but the vertical force acting on the inclined surface, and this weight is nothing but volume into density is mass into G is your weight. So density we know, G we know, volume is nothing but, so you have rectangle plus triangle, so 30, so this is 30, this is 20, so 30 into 20 is this portion area, and this area would be half 20 into 20, half 20 into 20. So this is the total area into perpendicular depth is 1, so this becomes your volume into rho g. So let's substitute, so 10 power 3, 9.81 into 60 plus 30 into 60, it is 600 plus 200. Okay, so this value comes out closer to 7.85 mega Newton. We have assumed that per unit width. Okay, so the total resultant force will be the resultant of Fh plus Fp square, and that becomes 12.3 whole square plus 7.85 whole square, everything in mega Newton, so you'll get 14.6 mega Newton. Well, we have assumed per unit width, otherwise everything can be done in per unit width and you will get mega Newton. So this is 1 unit width we have assumed, so you can add mega Newton per meter. So the answer is C. The other way of doing this would be take this separately, the first part, find out the pressure diagram for that, and the volume of that would be the resultant force, which is in this way. Take the inclined part, the pressure diagram is in this way, the pressure diagram of this. Same, in the similar way, find out the volume of the pressure diagram, the net resultant force is this. So you have two forces, one on the vertical wall and the other on the inclined wall. So resolve this inclined wall force into horizontal and vertical. The horizontal added to this top wall horizontal force, you should get this Fh, and the vertical Fy will be the resultant of this in vertical dash. So that is the other way of doing it, only by pressure diagram, but this is more simple approach. Thank you. Answer is C. Thank you.